So for today and Friday, we are going to talk about exponents. We're going to see exponents a lot. And I would say it's not a difficult topic, but it is definitely a new topic. But it's new, but it actually relates to what you learned back in Algebra 1. So I'm going to write down a few things first before I officially start. For example, okay, what is this? Okay, now I'm going to use this side as rules, and then I'm going to use the right-hand side as examples. And I urge you to do the same because sometimes the rules could be confusing, but an example could really clarify your thought process. For example, if you have x squared times x cubed, what would it be? It should be x to the what power? 5 or 6. Okay. Is it 5 or is it 6? Do you add the exponents or do you multiply the exponents? But why do we add them? Okay. Now, if you say because you're multiplying, so you add the exponents, now that's the rule. That's not the meaning, though. That's a meaning. Okay, so the way you want to succeed in this topic is that what if you don't have the rules? Could you still get the answer? Absolutely correctly. And you say, well, yeah, because the meaning says x squared, meaning x times 6. X cubed, meaning x times x times x. So therefore you get 5x is multiplied by itself, so x to the 5th power. And that means from this example, you know that you are going to add the exponents together when they're multiplying. So now I'm going to also give you one other example too. What if I have 2 squared times 2 to the 3rd power? What does that equal to? It'll be 2 to the what power? 5th power, right? You see the parallel right there. But one thing I want to highlight is this. First, what do we say about these two numbers? They must be the same, right? Yeah, well, exactly the same. Okay, they must be exactly the same. Can you say like terms? We usually use like terms when we are adding and subtracting terms. So I would say they just have to be the same. Okay, and you do not multiply those two numbers together because the meaning is that, oh, you have 2 of the 2's together and you have 3 of the 2's together. And therefore, how many 2's are multiplying together? There are 5 of them. So if you're wondering sometimes that, oh, why don't you multiply these two numbers together to get 4? Because we don't. That's not what the meaning says. It'd be strange to make this number. Like if you, some people would attempt to do this. And if you understand the meaning, you'd be like, what kind of nonsense is this? Because that's clearly there are 5 copies of 2's multiplied by itself, not 4's. So this is the kind of argument that you need to have for yourself before you start this, okay? All right, another rule, x to the m and then raise to the n power. Okay, I think we talked about this yesterday. Let me just go over this again. So just like that x cubed, and then we square it. What does it mean? What do we have? This one is x to the 6th power. And the reason is because when we say square, it means, well, multiplying by itself, right? So that means how many x's are multiplied by, how many x's are being multiplied together? 6 of them. So that's a meaning. And that allows you to say, oh, that is where you will multiply them together. Now, I can tell you how this whole thing is going to run, okay? You do a lot of exercises. It becomes part of your intuition. But if you are slacking, if you say, I'm going to just wait until the day before the quiz or test to take care of this, then I would say it's not likely going to work well for you. This kind of stuff, and I say this because I did not do well when I first learned this. Okay, so are we good so far? Yes? All right, now, that's another thing I want to show to you. You know what x squared is, right? So let me go ahead and dissect this a little bit. Let me show you something that is hidden. Look at this 2, okay? And I want you to see this 2 as 2 over 1. Are we okay to say this is 2 over 1? Yeah? Okay. So let me go ahead and establish one simple fact. And the fact is that the numerator is always the power, which you have been seeing the whole time. So when we say x cubed, the 3 is the numerator, that's a power. And where I'm getting at is that I'm going to establish something more. If I have x to the 1/2 power, the denominator is the root. Okay? It's the root. So that would equal to square root of x. Okay? If I have something like x to the 1/3 power, that would equal to cube root of x, which we did yesterday. Now, something that you're about to see is this. What if we have x to the 5/4 power? Okay? That would mean x to the, well, now that's actually what I want to say. I want to say 5th root first. No, I'm sorry, 4th root. My bad. 4th root, because the denominator is 4. And then the whole thing raised to the 5th power. Now, you may also change the order and say, let's go ahead, raise to the 5th power first, and then you do the 4th root. That's okay too. However, I would tell you, I would share with you that this is highly preferred. Okay, they're both right, but you are always advised to do the root first because you always want to bring down the number. Let me give you one quick example. What if you have a number like this? Okay. So now what we expect is that when you look at the exponent, you're able to tell that this is the, well, hold on, let me make it smaller. You can tell that this is the root, and you interpret the root first. So we ask, what's the 4th root of 16? What multiplies itself 4 times? We get you 16. 2, right? So the 4th root of 16 is 2. And then let's go ahead and raise it to the 5th power. What's 2 to the 5th power? 32. So therefore, this ugly thing is equal to 32. So you have to get yourself into a routine that you spot out the exponent, and then you go into a little program in your brain and says, okay, the root is the denominator, the top is the numerator. Oh, sorry, I mean the denominator is the root, the numerator is the power. Yes, sure. So let me just go ahead and write this out. What is the 4th root of 16? 2. And then you raise it to the 5th power. So it becomes 2 to the 5th power, which is 32. Okay. So we're going to see some wonderful things here in just a moment. And before we go into the actual worksheet, one final thing that I'm just going to ask because I am a little bit worried. So I hope you can prove me wrong that I don't need to worry. How do you do this? Okay. Does it hurt your eyes? I hope it does. I hope it does. What's wrong? Common denominator, right? Okay. So if you say I'm not, so we're going to see something like this in just a moment. So I just want to make sure that all these things right here, okay, you are putting them well under your radar. And when we use them, you use them well. So any question? Okay. If you don't have any question, let's move on to the worksheet. I mean, the notes.